The James Webb Space Telescope, the most advanced instrument available to humans for studying the universe, has produced yet another groundbreaking finding. Pluto was once thought of as a lifeless frozen rock in the far reaches of our solar system, but the recently released images of this frigid planet are changing our perceptions of it and revealing astonishing and thought-provoking revelations. Pluto is now showing itself to be far more complex and active, with evidence pointing to hidden motions. Geological motions and intricate chemical patterns that are inexplicable. These remarkable discoveries have left scientists stunned and perplexed. At the core of this new knowledge lies, once assumed to be a frozen stretch of nitrogen ice, Sputnik Planitia, the well-known heart-shaped area on Pluto's surface, is now suspected to hide a massive liquid ocean behind its icy shell, which is shielded by multiple layers of ice. Scientists are currently investigating the potential that microbial life might be flourishing in these subterranean depths, which could be one of the most important findings in the search for alien life shielded from the harsh conditions of space. Towering ice mountains rise to heights comparable to Earth's tallest peaks, while vast plains remain remarkably smooth, suggesting that geological activity has occurred relatively recently. This level of dynamism was completely unexpected for a world that was once thought to be frozen in time. Heat from Pluto's core drives convection beneath its icy surface, causing nitrogen ice to shift slowly, much like a slow freezing lava lamp. These processes reveal a planet far from static, as we can see in these declassified images. Finding microbial life on Pluto would fundamentally change our understanding of habitability in the universe, demonstrating that life can exist in places previously thought to be inhospitable. Pluto now joins an expanding list of icy moons and planets that may harbor life, along with moons like Europa and Enceladus. Beneath their frozen exteriors, water and organic molecules could interact in ways that spark the fundamental chemistry of life, even if we are not considering advanced life forms. Almost the same size, Charon is unlike any other body in the solar system. The two bodies pull on one another, creating internal heat and causing dynamic changes on both planets. Charon itself is riddled with secrets. None of these remarkable discoveries would have been possible without the James Webb Space Telescope. Its deep canyons and distinctive reddish hue imply a shared history with Pluto, suggesting that material from Pluto's surface may be transferring to Charon, hinting at a chemical exchange that could contain the building blocks for life. Through the analysis of Pluto's surface and atmosphere, the Webb telescope has discovered organic compounds and temperature variations, providing scientists with a picture of a planet far more dynamic than previously thought. Its infrared capabilities allowed scientists to peer beneath Pluto's icy crust, revealing details that previous missions could not uncover. Despite being thin, Pluto's atmosphere is extremely complicated, consisting mostly of nitrogen with traces of carbon dioxide and methane. This results in a haze that extends hundreds of miles above the surface, and as Pluto travels through its extended orbit, its atmosphere undergoes drastic variations. These atmospheric dynamics provide a unique glimpse into processes that could occur on distant worlds, providing insights into how celestial bodies adapt to extreme environments. When it is closer to the Sun, the surface ice sublimates into gas, creating a temporary atmosphere. As it moves farther away, however, this atmosphere refreezes onto the surface, creating a unique cycle unmatched anywhere else in the solar system. Researchers are especially interested in how these compounds might interact with the water ice beneath the surface. Could they serve as the building blocks of life carried onto the surface oceans where they combine with other organic molecules? One of the most striking features on both Pluto and Charon are the reddish patches scattered across their surfaces, which are believed to be caused by tholins, complex organic compounds formed when ultraviolet light interacts with methane in the atmosphere. These stolons not only color the landscape but also point to prebiotic chemistry, a critical chemical process that could serve as the precursor to life. This intriguing issue is one that scientists are keen to investigate. The possibility of a huge ocean beneath Pluto's icy crust, kept liquid by heat from radioactive decay in Pluto's core, is one of the most groundbreaking discoveries about the planet. This ocean could cover a large portion of the planet's interior on Earth, where similar environments like deep-sea hydrothermal vents are teeming with life. If Pluto's oceans provide similar conditions, they could host microbial life or even more complex ecosystems. Our knowledge of where life may live might be altered by discovering the mysteries under Pluto's surface, showing that even the most improbable locations could be teeming with activity. For decades, Pluto was written off as a minor world, but these new findings demonstrate just how little we actually know about our cosmic neighbors. As new data keeps coming in, the excitement surrounding the questions that still remain unanswered grows, and the discoveries made by the James Webb Space Telescope are just the beginning. The release of classified images and data from the telescope has sparked a great deal of excitement and speculation. Governments, scientific institutions, and the general public are all fascinated by what Pluto's secrets might reveal about the broader universe. Future missions include orbiting probes and landers intended to probe Pluto's mysteries further. These missions could confirm the existence of the hidden ocean and offer the first direct evidence of life beyond Earth. Some even suggest sending robotic submarines into Pluto's hidden ocean, which would be an incredible feat of engineering and one of humanity's greatest space exploration accomplishments. As technology advances, the dream of getting up close and personal with Pluto's secrets is becoming more and more feasible, which could deepen our understanding of the universe in ways we never would have imagined. Pluto's surprising geological activity and the persistence of its hidden ocean may be explained by its interactions with the solar wind, which produce unique magnetic phenomena. Although Pluto lacks a strong magnetic field like Earth does, Pluto's interactions with the solar wind generate enough heat to drive convection within its icy crust and maintain a potential liquid ocean beneath the surface. This heat may originate from Pluto's radioactive core, with radioactive decay releasing energy over billions of years combined with gravitational interactions with Charon. Pluto's interactions with the solar wind generate unique magnetic phenomena that strip away parts of its atmosphere, leaving behind a trail of ionized particles that stretches into space. A unique glimpse into how tiny planets and dwarf planets interact with their stellar environs has been provided by the James Webb Telescope's discovery of odd energy patterns encircling Pluto that point to interactions between the planet's magnetic environment and the Kuiper Belt. Pluto has created new opportunities, demonstrating that even the most remote worlds have tales to tell as technology develops, and the discoveries made there are only the beginning. Missions to the Kuiper Belt and beyond will allow humanity to explore the unexplored regions of our solar system. From human expeditions into the Kuiper Belt to robotic subs exploring frigid waters, the distinction between science fiction and reality is becoming more hazy. Pluto serves as a reminder that the cosmos is a huge, enigmatic, and surprising place. Once believed to be a desolate, frigid planet from its dynamic geology and mysterious atmosphere to the possible presence of buried seas and organic substances, Pluto has shown itself to be everything from typical. Everything we believe to be true about the furthest reaches of our solar system is called into question by this far-off dwarf planet. Pluto has evolved from a remote curiosity into a focus of scientific investigation because to the declassified photos and groundbreaking discoveries made possible by the James Webb Space Telescope. These discoveries serve as a reminder that mysteries lurking in the deepest regions of our solar system, just waiting to be discovered. Pluto is a representation of opportunity and promise. New tasks are constantly inspired by its secrets. Could Pluto support life? What other mysteries lay under its frozen surface? What can Pluto tell us about the beginnings of our planet? New technologies and questions about our role in the cosmos. Pluto's journey is far from done. Every new finding serves as a reminder that, if we have the courage to investigate, the cosmos is huge, strange, and full of surprises. What are your thoughts on the discoveries made by the James Webb Telescope concerning Pluto? Do you think it may contain secrets or life? We're not quite prepared to reveal, so please leave your comments below and remember to subscribe for more amazing cosmic tales. With every new discovery, humanity's comprehension of the solar system advances. The James Webb Telescope has opened a window to a world we previously believed to be ours, only to discover that Pluto is a complex, dynamic body with secrets that we are only now starting to uncover. These discoveries not only alter our perception of Pluto but also call into question our presumptions about extraterrestrial life as we continue to explore its surface, atmosphere, and hidden depths. Some of the most important questions regarding its potential for life will likely be addressed by future missions. Could the ocean beneath Pluto's icy surface support more complex ecosystems or harbor microorganisms? Could Pluto's peculiar atmospheric phenomena provide hints about how other far-off exoplanets might evolve? Continued research is essential to addressing these and many other questions. Maybe changing our perspective on other planets' habitability. Other scientific tools and exploratory missions, in addition to the James Webb Telescope, will help us better understand Pluto. Orbital probes will allow us to examine Pluto from new angles, and landers and possibly future rover missions may collect samples straight from the planet's surface. The next steps in exploration may confirm the existence of the liquid ocean beneath Pluto's crust, offering concrete proof that life can exist in previously unthinkable conditions. There is also the possibility of further exploration and a deeper dive into Pluto's geology and atmosphere. Even though Pluto is far from the Sun, it manages to generate internal heat that drives geological and atmospheric activity. This heat, which is likely produced by the radioactive decay of elements within Pluto's core, could explain the movement of ice on its surface, the possibility of a subsurface ocean, and the interaction between Pluto and its moon. Future missions hold the promise of not only revealing more about the dwarf planet itself but also shedding light on the larger mysteries of the universe. As technology advances, we may even see the dream of sending robotic submarines beneath Pluto's frozen surface realized. Such an undertaking would represent a major milestone in space exploration, allowing humanity to explore one of the most distant and mysterious bodies in our solar system in unprecedented detail. Since the two bodies' gravitational pull causes tidal flexing, which might further fuel geological activity, Charon also contributes to this heat production. The fact that Pluto still exhibits so much activity in the face of such extreme conditions challenges conventional wisdom and indicates that our understanding of what is possible in space is far from complete. This ongoing investigation into Pluto's geology and atmosphere is changing our understanding of how planets and moons evolve in the cold outer reaches of the solar system. Whether there is microbial life on Pluto, a subsurface ocean on other moons, or the discovery of life-friendly habitats outside of our solar system, the ongoing hunt for life on far-off worlds, driven by the James Webb Space Telescope's discoveries, will influence the next stage of space exploration. As we continue to broaden our perspectives and discover new planets, the quest to comprehend the prerequisites for life in the cosmos is just getting started. In conclusion, Pluto continues to be a major focus of scientific inquiry and interest. The discoveries made possible by the James Webb Space Telescope mark just the start of humanity's quest to comprehend the universe. As we continue to investigate its surface, atmosphere, and the depths under its ice, Pluto, once believed to be a frigid, dead planet on the boundary of the solar system, has shown itself to be a dynamic, vibrant world full of surprises. Pluto may provide the answers to some of the most important scientific issues of our time, but its secrets are still far from being solved.